So today we are talking about prototyping, and this is the last step in your project deliverables. So you're going to need to know how to prototype, and after today you're going to go, oh, prototyping's easy. Well, I'm going to simplify it. It's not necessarily this easy in the real world, but then again your project isn't really a real world application either. Because in the real world it would take you a year, 2 years to build the thing, and you'd probably spend 6 months, maybe 4 months, 4 to 6 months, putting together the requirements, the analysis, and doing the design document, possibly putting together the prototype. So we're doing it all in, what, 10 or 15 weeks or something. You know, some of us are doing it in a week because they haven't turned it in yet, or probably won't be able to turn it in. So here's an outline of the topics I'm going to talk about today, the definitions of what prototyping is all about, talk about different levels of fidelity in terms of prototyping, uses of prototyping in the design process, prototyping approaches, prototyping technologies, examples of prototyping, and then I'm going to discuss what you need to do for your projects. So this is the last piece of the last deliverable, and if you haven't gotten the memo, we're not doing presentations this term because we have too many students in the class and not everybody's showing up. So I'm Xing the presentation. So there's an extra 5 points that you're going to get that it will be free. You don't have to do anything for those 5 points. So that's a freebie. Don't ask me about the presentations either. And I know it's not you guys sitting here, it's people at home that will eventually figure out, oh, when are we supposed to do a prototype? Oh, yeah. When are we supposed to do a presentation? I better send her an email message. Yeah. All right, so, and that was for you guys who are listening to this video at home and are not sitting in class right now. So now I'm talking to the home audience as well. So the imaginary people who aren't sitting in front of me right now. All right, because I know you're listening. Because people have corrected me on some of the things I've said in some of my videos. So I know people are watching the videos. Or they said, hey, you said in the video. I'm like, yeah, so? I give away all the secrets to all the exam questions in the videos too. So anyway, let's get back to the focus of the lecture today on prototyping. In terms of definitions, prototype should exhibit something, make something vivid in the product. Why are we prototyping? Well, because you're not building the product. And if you're following a software development lifecycle model like the waterfall model, it's a year and a half, 2 years before you actually deliver the product. Meanwhile, the customer's sitting there going, what are you working on? Can we see what it looks like? And you can't show them the system because the system hasn't even been started yet because you're still doing the requirements and the analysis and the design. And so long story short, you come up with this prototype, and the prototype represents what you're going to be building, perhaps, and then you can show it to the customer, say, here it is, here's what we're working on, here's a prototype, and oh, this isn't the real system, this is just a mock-up we've done so far. And that type of prototype is generally what's called a throwaway prototype. It's just done to satisfy the customer, to show off to the public, to get investors to give you money to continue working on this, to, I don't know, present at a trade show or something. You know, here's that prototype. The real product is made with different tools, and it has different features, and it actually hopefully works. The prototype is not really a functional application in this type of prototyping environment. It's not a functional application. It's a mock-up. What it does is it makes a 3D real-looking thing out of something that's not real, because people don't want to read 20 pages of documentation. They want to look at something. So it's easier for them to understand. It should hopefully demonstrate some look and feel, perhaps, or it should demonstrate maybe some features that the system's going to have. Should resemble a system. Doesn't have to look like the actual system. Should suggest what the application will do, what the essential characteristics are, what it might look like, what it might be used for. That's one type of prototyping. And this is a prototype that is created at your particular stage in the process. So you've already done analysis. Well, hopefully you did the requirements, you've done your analysis, you've got your design ready to go. This is the type of prototype that you would be creating and you are going to be creating for your projects. It's a throwaway, let's show this to the customer, kind of this is what we're putting together, because it's been 6 months and you haven't given them anything yet. So Other types of prototypes, and just to deviate a little bit from the slide, and I'm going to talk ahead a little bit, and then I'll just kind of go through when I get there and skip through whatever as I talk ahead on. But we have prototypes that are also used before the requirements are gathered and before the requirement specification is put together. That purpose of that particular prototype is not to show the customer what you're working on, because you haven't really started working on it yet. It's to get information from the customer, because either you don't understand what the concept is, which is highly likely if you're a business person, software engineer, and you've got somebody in a trade field, you know, maybe an air conditioning controller or something. You don't know anything about air conditioning controllers. You know, what features is this thing supposed to have? You know, how's it supposed to work? What's the user interface supposed to look like? So you can put together what's called an envisioning, and it's a requirements tool. You put the prototype together and show it to the user and say, is this what you're talking about? And the user looks at that and goes, no. Where's the button to change the temperature? Oh, there's supposed to be a button on this thing? Oh, okay. Oh, this is not a computer program? No. So you get feedback from the users and from the people, hopefully, who are going to be using and maybe buying the system. And they're the ones who are asking for these features. So it validates, verifies, and validates, you know, the system itself, verifies the requirement, helps you in creating the requirement specification. That's yet another category of prototypes. That's also a throwaway, because you're not going to use that type of prototype, you know, to build the system from. And that's one that needs to be easily changed. And these are generally low fidelity ones, which are, and I'll talk about the fidelities in a few minutes. This type of prototype, it slaps together quickly, and it has to get changed, because whatever you're putting together is wrong. You say, okay, this is what you asked for, and here are all the features, and then the customer's going to correct it. It's not necessarily representing anything that's going to be built. So using tools that can easily correct this prototype, it's usually paper-based, or it's usually a very non-computer, you know, just pieces of paper, 3x5 cards, maybe a sketch, a drawing, or something like that is used for this. For the first type that I talked about that you're going to be creating, you can do it with a drawing, you can do it with a sketch, but usually at that point the customer wants to see something on the computer. They want to see like a program or a website or something a little higher fidelity. However, for your projects you don't have to do that. You could do a paper-based prototype for your projects. So that's two different types so far. We also have like a third type of category that falls into the proof of concept prototype, where you've done your requirements, you're doing your analysis, you don't have your design yet, because you're working with cutting-edge technology. You don't know if the signal's going to carry that far. You don't know if this receiver's going to have a strong enough signal, or this technology is going to work for what it is you're trying to do with this technology. So you put together what's called a proof of concept prototype, and you prototype the concept, just what it is you're trying to prove to see if it works. It's kind of like, let's try it before we decide to use it. So it's in between requirements and the design document while you're performing the analysis, and the purpose of that prototype is for the development team. The customer never sees it. It's for the development team to go, here's how the algorithm is supposed to be implemented. Does the algorithm work? Does the encryption actually encrypt the file correctly? Can we use the file? And you're using it to prove, perhaps, that this is the design we want to go with, and that because you don't want to build a design that you can't actually finish. Now, if you're not using cutting-edge technology, there's no need to do that. You know, you're going to build it with, you know, using an Oracle database. Well, they've been around for years. You know, common SQL interfaces, HTML or something. There's no need to prove anything there. So that one is kind of rarely done. And then we have yet another form of prototyping. So don't think there's just one type of prototype out on the market. The last, but most important and most commonly used type of prototype is rapid application development. This is what Google does, and companies that want to be first to market on something, they never put out the real product. They always put out the prototype first. So on cutting-edge development work that needs to happen fast, they start on the development before they start on the requirements or the analysis or the design. They switch the order of everything. They start with the implementation. What they're implementing is a prototype because they have no idea what they're building. Half of it has features. Gmail is a good example of that. You know, when Gmail first started, it never had any of those features that it has today. In fact, it's still getting new features and stuff added to it. So what they do is it's sometimes called rapid application development. Sometimes it's called prototyping. So it is a form. Huh?
Do they call that as a beta version?
They do call them beta versions. In fact, Netscape was the first browser that did that. Now, Internet Explorer, you can get beta versions of Internet Explorer. They're kind of like work in progress, you know, process or whatever. You know, they're not finished yet. They're not tested. They're not troubleshooted. They might have bugs in it. And then sometimes they have features like some of the IE and Internet Explorer versions that I've looked at. Another company does the same thing. Some of the features go away. You know, they tried this. They tried this search thing out for a while, and I think it was version 7, or I think it was. I was using the beta for a while until I got rid of it because it kept crashing. But you know, it had all this, you know, really bad, in my opinion, bad search features on it. I didn't like it, and I'm glad they took them out because you know what you do is you put it out there, and people use it, and then they go back and they comment on it. That's what beta testers, you know, let the public beta test it kind of thing. And then the customers come back and say, hey, you know, we don't like the search features, or this thing keeps crashing all the time. Why does it keep crashing, you know? They're doing your testing for you, but they're also deciding on your features. They're writing your requirements. They're doing your analysis. They're doing your design work for you. And you gave them a prototype to work with, essentially. It wasn't a finished system. So a prototype, by definition, can be anything that envisions a concept that is used to communicate something to the user, or to demonstrate something, or to be used in some form of communication back and forth. It can be the user communicating back to the developers, or vice versa. So it doesn't really matter which form, but yeah, Google does that all the time. You know, and what ends up happening is after a couple of, you know, releases and you get tons of people using it, then what they do is in the background they're actually working on the real product. And then when the real product is actually ready, they take the prototype, get rid of it, or substitute it with the real product, and then start building on that, you know, prototyping new features to add to the real product. So eventually the thing gets written from the ground up in a logical fashion, because what ends up happening with prototyping, there's no analysis, there's no requirements, the features may not necessarily be implemented in the correct way. You know, it's like trying to build a house one toothpick at a time. You know, you lay a foundation, you plan out the development a little bit better, you get a stronger building. So, long story short, same thing happens with software. So you take the prototype out, you replace it with the program that actually has all the features that people like, and then it happens usually overnight. And then actually Yahoo did that not too long ago. In fact, they continue to do that. You know, you click, you go into the application. It goes, look, new field. Would you like to use the new one? Like the Maps programs did that recently, or a couple of times recently. And all of a sudden, it's like, oh, it looks different now. That's because they just put the real one in there. They took the old one out, put the real one in, kind of thing. So, all right. So now I'm going to talk through the slides. I've kind of see what I missed here. Prototypes are used for envisioning. We've seen that. I just talked about that. Are used to help one visualize things that don't actually exist. That's can actually be a characteristic of all the different types I just talked about, the 4 different types. They could be used for designing media systems, interfaces. A lot of people think that prototype is only used for the user interface design. Kind of misleading. It can actually be used for features. You know, like, for example, like report menus. People go, how come there's no report to print out cost of goods sold or something? And then people go, oh, I don't know, we didn't think about that concept. We're not accounting people. Oh, okay, you know. And then you can add features to the system that didn't exist. Also, pre-testing media systems interfaces, presenting interface ideas as well. New things that may not have existed. I always forget my timepiece. There we go. I don't have a watch on my computer when this is up in full screen mode. So it's kind of a bummer. So, envisioning into design. So this one was envisioning in terms of its use, perhaps, interfaces, features, stuff like that. Also the design of the system. Visualizing concepts exploring different alternatives, because if you have a couple of different choices, you might want to use, do we want that feature on the left-hand side of the screen, or do we want it on the right-hand side of the screen? Do we want there to be context-sensitive help, or do we want to turn off all the help? And in the past, what companies have done is put all those features in there and then allow the user to select, I want expert mode, or I want novice mode, or, and then you can kind of pick and choose what it is you want. But companies right now aren't really putting all that stuff in there anymore, because most people would go for one or two of the default modes, essentially. So they kind of, that's a lot of work to put in all those options. Resolving feature details, developing interaction scenarios, usually showing use case scenarios, and that's another approach actually I didn't mention so far. Sometimes it can be used for testing, and actually for visualizing use case scenarios. So you put together the prototype. It says, this is how you print the form out. Oh, and then you can kind of say, oh, this is how I'm supposed to do it, and it demonstrates the use case, which is pre-testing. Also the concept. Now, what if we're working with a concept no one's ever heard about? Everyone knows how to do email. That's pretty no-brainer. Actually, there's a lot of people who don't know how to scan checks. Chase Bank has got this new thing on an iPhone. You scan the check, and it goes into your bank account automatically. Well, how do you know when they developed that? How are you going to pre-test it? Well, actually, they gave the service out for free to users, and they walked them through on the telephone, and they said, and what they were essentially were a focus group that said, hey, let's see if you can do it. Scan your check. They're like, do what? Take your phone and scan your check. What? Well, people are afraid to, movie theaters, you can actually walk up with your phone and your ticket's on your phone. Who does that? Nobody. Nobody does that because they don't know how to do it. So I think there's something wrong with the concept because users don't know how to do it. And in fact, there's features in a lot of software programs that users never touch. Users never know about because they don't know it exists. They don't know how to do it. So you can actually put together a prototype to see why can't a person why don't the people use the tickets on the phones? Why don't they scan their checks for deposits and stuff? And I can tell you from personal experience of being in this country when ATM machines first came out, nobody used them. This was like in the 70s, I believe. Don't quote me on the date, but I was definitely around, and I do remember the ATM machine when it first was invented over here. Nobody had any faith in it. They didn't want to, well, people still don't have faith in it, but they didn't want to put their checks in there. They'll use it for withdrawals, but they didn't want to put checks in. Now you don't have to use an envelope. Now you just put the check, you just stuff all the checks in there, and it works for you. I wouldn't put money in an ATM machine, though, but that's all it's secure. They tell you can. I don't know if I would do it, though. Long story short, they had tutorials in the banks where they put together a system and they showed people. They still do it. They still have tellers that go out and help. Usually it's the elderly people. Help them figure out how to use the ATM because they don't want to wait. They complain about waiting in line. It's like, well, you don't know how to use the ATM. Hold on, let me show you. And then they set up terminals in the bank, actually, that have demos. They used to have demos. Just the same way now, they have terminals in the bank that show you how to do online banking. You've never noticed? Actually, Wells Fargo has this all over the place. You walk in and you see the little terminals there. They're actually live. They have internet access, but they sit you down and they can actually show people who don't have computer skills or how to go online and check their balance and do everything. Well, that is actually a form of prototyping. And it's probably through training. So you can actually kind of put together a prototype, send it to a focus group, put it in a bank, do something. Well, what are people having problems with? They can't find the button, or the wording is wrong. Or, in fact, that was what the problem was with some of the earlier ATMs. They used words like, do you want to transfer, deposit, withdrawal, verify, and it's like, what? I just want to get money. So, change the wording. Get money, press right here. Cancel, press right here. Make it easier. Well, software programs, if you've ever tried to use Visio as an example, but it's not intended for the average user, it's intended for the engineer. So you got to be able to know what kind of chart you're trying to create, what you're trying to do. You have to know the vocabulary that goes along with it. But knowing users' vocabulary is an interesting thing. Metaphors for icons and things, interesting. Can they follow instructions? Can you make this work? Do you know how? I mean, everyone knows how to use a mouse right now, but in the old days, people didn't know how to use it. In fact, still today, people don't know how to use the wheel on the mouse. And people, and I'm one of them actually, I don't know how to use the new touch controls on my MacBook. I'm learning, but I still haven't figured out all the things that this touch thing will do. So I finally got most of it down, but the gestures are kind of interesting. So it's not something I've never used before. So how am I supposed to know how to use the product unless somebody gives me a prototype or tests me? Make it easier. So it does suggest alternative ways that might be used in terms of making the feature more vivid. So also envisions for presentation and discussion. Eventually you'll have to deliver this product, hopefully, or perhaps you have to give a status update or something. So you can use the prototype as a mock-up, as a presentation tool, something to show the customer this is what we've implemented. These are the features that we have working so far. This is what we have left to do, stuff like that. So the interface designers for discussion, to programmers to guide them through the implementation. Marketing and management people. In the old days, the marketing people took pictures of the prototype and put it on the box, on the cover of the box. Well, it didn't look anything like the product, but that's what they were given. They were saying, here's what it looks like. Okay, they put, and then they had feature lists that matched the prototype, not the product, as well, which was good and bad at the same time. To users to get early feedback, to focus groups, marketing people, venture capitalists, all sorts of different focuses for that. So now I've talked about the focus and the use of the prototypes. Let's talk about the different types of prototypes. And they come into what's called fidelities. So we have the fidelity of the prototype, which is a common terminology used for it. High fidelity versus low fidelity. So the degrees of the fidelity are describing the functionality of the system. And as the degree goes up, we have different increasing functionality. And a greater set of allowable inputs, outputs, more realism in the interaction and the style, greater detail in terms of the visual appearance perhaps. So you have to do a low fidelity prototype for your projects. And your project, low fidelity, can be paper and pencil if you want. You can also go higher. You can make a PowerPoint presentation if you want on your project. So what you're doing is you're demonstrating what your project is doing. So you might have feature lists going on. You might have, in fact, if you've done screenshots for your design document, you can take those screenshots, put them in a PowerPoint, and voila, there's your prototype. So what is a low fidelity prototype? Well, it's usually paper and pencil, bar napkins, post-it notes, glue, photocopies, some common tools, scissors, tape, glue. Not too fancy. They're very, very low fidelity by nature. So use standard office supplies, no computer involved. And yes, you can have a prototype without a computer. They do exist. Modularity is required. The user actually has to put the pieces together themselves, which is why I kind of like PowerPoint, because it's easier. You just press a button, it goes from one slide to the next. You don't have to hold, if you give me a bunch of pieces of paper, I'm not going to know what to do with them. So if you give me a PowerPoint presentation or a Word file, you can probably figure that out. Interactivity is involved. The human has to actually play the computer, has to structure the pieces of paper. And testing is best done as a team because you need the developers to actually kind of put it together. So that's as low as you can go. So let's go into a one-dimensional. Then we start using media and tools. So we start using scripts, scenarios, role-playing exercises, perhaps, where the human plays a computer. So everything past the low fidelity, like a one-dimensional, could be a PowerPoint slide. Actually, could be a one-dimensional because you're using tools for it at that point. You're putting it on a computer, it automatically comes up one level. So it can simulate the complex functionality, the behind the curtains kind of scene. perhaps. It's all hard-coded. It's not something where you're actually getting information from the user or doing something. You can put together use case scenarios. You can put together a storybook, something of that nature. One-dimensional prototypes are made for websites all the time. That's where the storyboard comes from, and the site map. You put together a site map and the storyboard. Well, that's a one-dimensional prototype for the website. If you're not familiar with the concept, the site map shows you all the different pages and how they work together in terms of the navigation system. And then the storyboard shows you how one page is used for hobbies and the other one is used for products and the other one is used for travel or something, and how the pages are organized in terms of their content, their story that they're trying to present. So if we go up a level, we have the two-dimensional media and the tools that are used for that. That would be screenshots. That would be, taking the actual program or an existing program as an example, and you're building an upgrade to that program, and you're going to build a new menu on the left-hand side. So you take a screenshot of that program and you draw a little arrow, say new menu right here. And this is where I'm going to put the new menu. That would be a two-dimensional kind of thing. Screenshots, storyboards also fall into the two-dimensional, depending upon how much information is being put on there and how you can flip through them. Flipboards. And remember, I know as kids, when you start learning how to draw and stuff like that, if you ever figured it out, you take like 50 sheets of paper, all the same size, and you put, that's a flipboard actually. You put little pieces of a cartoon character on it, and as you flip up the pages, the guy moves around and stuff. So that would be two-dimensional. That would be two-dimensional in terms of media tools. Collection, post-it notes, cuts, paper, cupboards, mock-ups, all sorts of different things. Now we got three-dimensional. If you're an architect and you're building a house and you want to show the customer the design of this house, you're going to build a three-dimensional. It's not a puppet, it's a model. So a physical model. You got a hobby store, you buy the airplane models. Put those together if you can, and then that's a three-dimensional because it has sides to it. It's an object that you're building, that you're showing. So architectural designs, rarely is computer software ever put into a three-dimensional mode. But if you're looking at animation or concept stuff, it could be. We talk about 3D games these days. This is a little slightly different concept because it's hard to actually, or you could, I guess, put together a model of a 3D simulation or a game. And it'd be a real life kind of representation with objects in it. But usually computer animation would be used instead of that. Videos. Videos are pretty popular. Interactive software, rapid prototyping. In fact, they put together, if you haven't noticed, well, in the old days, so the airlines have done this actually. I'm trying to think of an example. The interactive videos, they're not really interactive, but when you get on the airplane and they shut the doors and they put on this little 2-second video about exit signs and air masks that fall from the ceiling, and this shows you how much I pay attention to those videos. I don't know. What the safety features of the airplane, of the whatever, the 740 whatever. So that's a prototype. That is a 3D media tool video presentation. Prototyping what would happen in the case of an emergency. And in the video it says, throw your hands up in the air and scream frantically so you scare everybody else around you. It doesn't say that, but instead you're supposed to find your nearest exit or something. I always like the pictures of the blow-em-up ramp that comes out of the airplane. I haven't actually seen one live yet, but they look kind of scary. Like 2 seconds. They open the door and this ramp starts opening up, comes out. I'm like, wow, I've never seen when I go to blow up like air mattresses and stuff, they don't blow up that fast. Like when you go to the beach or something, it just doesn't work that fast. So I don't think it actually works that fast, but I've never seen one work. So. I've seen the prototype though. So I'm going to base everything off my prototype experience. Interactive software prototyping tools. If we were going to do this for a software development company, we would use, and this is not available anymore, but in the old days there was this thing called HyperCard. It was Apple's development tool. Because, if you're from the Apple world, everything was graphics on the Apples in the old days. And if you were an artist, You're a developer, you're going to put together a beautiful prototype, you're going to use an Apple development environment, HyperCard, put something together. And then, yes, we had prototyping tools called Director and Flash. And everyone looks at Flash and goes, that's not a prototyping language anymore. It's a full software engineering development language. It started out as a prototyping language, or was used as a prototyping language. Now you can't get past a website anywhere that doesn't use some Flash plugin. People develop, chemistry simulations, all sorts of animation with Flash. Flash is good for animation. Borderlines on becoming a full programming language these days. Director is a kind of a larger version of Flash, and I'm going to go through all of these in a lot more detail in a few minutes. Visual Basic, people argue with that one too. Visual Basic is a programming language. It's not a prototyping language. Yeah, but it's pretty easy. Okay, you're building a Windows application. It's going to use an MFC interface. It's going to have a Windows look and feel. You bring up Visual Basic, it can create some forms quite easily. Throw some items on the form. You don't have to put any functionality on that. Just create the main interface form with it. Press on compile. Oh, here you go. Here's your executable file. There's no functionality, but you got the same look and feel as if you wrote it in Visual C++. It's the same Windows interface. So, not bad for Windows prototyping. And web-based prototyping, if you're doing a website, you're probably going to do some sort of a web prototype. Dreamweaver, again, takes a lot more skills. Java applets, not used very often anymore. Not used for anything anymore. Probably because they are it takes a long time to download those things. They're very big, a lot of bandwidth required. So let's talk about, and it doesn't merit any time to spend on technologies that are outdated or no longer being used, or that no longer exist. But I just want to kind of mention the concept in mind, because there's other applications, open source applications, that sort of do what HyperCard used to do. But they're not on the Apple, they're made for Windows PCs. It was a system, and it was designed for non-programmers. And it was object-oriented in nature, and what it put together was a series of cards, interface cards, and here's what it kind of looked like. Here's some examples of it. And for purposes of the final, you don't have to know any of these prototyping languages, systems, or anything. It's just some examples to give you some exposure to it. But these cards kind of showed interaction. They were sort of like CRC cards, if you're familiar with object orientation. It kind of looked at objects, kind of looked at the application, what would happen. It looked sort of like a storyboard in a lot of ways. Didn't match too well with the application. It created something that didn't look like a computer application. It looks like 3x5 cards or something. So naturally it phased out. People said, I want something that looks a little bit more like a computer application, something that I can actually use. So then Director came along, and Director actually is good for computer animation, structuring images, creating movies, creating demos. So it had a central timeline, dealt with times and scenes, theater, metaphors, actors, stage, etc. It used a scripting language, still uses a scripting language, I say Director is still around, called Lingo. A little hard for people to learn. Not necessarily a prototyping language for a non-computer person. HyperCard was for the non-computer. HyperCard was kind of like iPhoto or something, or iMovie. Non-computer people who want to make a movie, who want to have a photo album, who want to put together a prototype. So Lingo, extensive object-oriented limitations. Lingo language not easily accessible for non-programmers, and 2 versions were needed for the Mac and for the PC, because back then people were still using Macs for all this stuff. So you had to get 2 versions of Director. And then along came Flash. So Flash was better suited for interface design, easier to learn, cheaper to buy as a development kit. Flash tended to bog down the system when a lot of elements are on the screen. Actually, still the case. If you've ever noticed how slow Flash runs, it's worth it in the long run, but it takes forever to load. That's even if you got the right browser plugin loaded. That's not even the problem. Once the browser plugin's there, you see the little Flash window, and you just wait, and you wait, and you wait. And eventually it loads up and you go, wow, that is really cool. Because it does look cool. But it's slow. Director is better for game development and complicated interface programming. Director is much stronger timer than Flash. Flash also uses the timer concept. Sacrifices some of the UI control for ease of use. So what they did with Flash is they took out a lot of the director features that weren't used for certain things. I mean, minimally used. Stripped it out, created it, called it Flash, and sold it for cheaper. You know, the development tools are cheaper. Plugins are readily available for almost every browser these days, except for if you're on an iPad. So, I don't believe there's some third-party browser, but it doesn't do a good job. There's some tools for the iPad, but it's still not supporting Flash correctly. So go to the Android market, and you can get Flash, no problem. So I don't know why they don't support it, but they don't like Adobe either. So I mean, they don't like anything that's not Apple, which is the problem. They don't want to support anything. Plus, also there's a little bit of controversy with what Flash supports and the capabilities, and it provides some security issues for browser control, stuff like that. So there's a few issues with the technology itself, but for purposes of prototyping, not bad. So there are a lot of simulations, a lot of prototyping, a lot of in fact, you can actually make something that looks like a computer program with Flash. You can run Flash on the internet. There's little computer applications that run. So Flash is a lot easier to use than Director, but not as feature-rich. So Flash is slightly cheaper, less powerful, no 3D modeling and animation, less access to hardware resources, no XML in Flash. There's XML capabilities in Director, though. Multiple timelines for individual scenes. Scripting language is now ActionScript. So we don't have to use lingo anymore. ActionScript is a little bit more widely used. A little easier. Still easily accessible for non-programmers, they say. Haven't personally worked with ActionScript, but I've had some students ask me some questions about it, and I'm like, don't think I want to venture out in that route. I don't know. I mean, I don't know anything about it, but from what I've seen, it seems a bit awkward to work with as a scripting language. I don't know, I'm more of a PHP or a Perl or a Python type person. So even Lisp or Scheme makes more sense to me than what I've seen from ActionScript, so I don't know. Visual Basic. So features of Visual Basic is the interactive definitions of the screens, how they relate through the interactions. Functionality, logic, programming, you know. You can actually create some small little Visual Basic functions that actually mimic some behavior. A little easier to learn in C++. More extensive, powerful language than HyperTalk, Lingo, or ActionScript, actually. Limitations, not really accessible to non-programmers. Who's got Visual Studio and VisualBasic.net installed on their computer? If you're a programmer, computer science type person, you probably do. If you're a business person, you don't. And that stuff's kind of expensive to buy, so you may not necessarily have it. Language gets very hairy very quickly as well, especially if you start doing some object-oriented stuff in it. And actually, you could probably build an entire application in Visual Basic if you wanted to. It's a programming language, so it's not limited to just prototyping. But compared to some of the other .NET applications, it might be easier to prototype in that, especially if you can mix in with a little ASP and stuff. So creates a lot of features, a lot of feature-rich, and a lot of interaction with other programming languages as well. Web-based prototyping, very popular these days. Assembled of tools, we've got HTML, static, interactive, scripting languages that work with it, images, maybe representing graphics. JavaScript can be used for the logic. Java applets can be defined for functionality. Dreamweaver manipulating system is as an example that insulates the interface designer from much of this detail and automates. So Dreamweaver, very popular these days actually. Used to kind of as a higher level interface to a lot of web development, makes it easier to actually create a lot of more functional stuff. So some prototyping goals. Showing the scenarios. Because once you start with the tool, you don't want to use the tool to determine what you're going to show. So you're hopefully going to have a vision of what it is you want to prototype. then you're going to find the right tool. So most people would, take a shortcut and do the opposite. Well, I have Visual Basic. Let's create a prototype in it. What can we show? And then they use Visual Basic and they go, oh yeah, I can do this and this and this and this. They end up building the application. Like, what does that mean? Well, who cares? All we see is this one feature you have on the screen. So consider the goals first. You need to capture the characteristics of the system or the device that you're trying to represent. You need to strike a balance, choose the appropriate level of detail to illustrate the idea. So in some cases, the less detail, the better, actually, because you're not burdening the user or the viewer of this with unneeded details. Picking the important details and concentrating on executing those well, and the level of details and the amount of information required. So do not do more than that's needed. So I've had some students give me some prototypes that were fully functioning programs. It's a lot of work. More than it's needed. Put together a PowerPoint for me. I'll appreciate that a little bit better. In fact, it'll be easier for me to look at too. Practical prototyping. Here's some advice. Remain flexible. This is why you don't want to do a real low fidelity. If you take pieces of paper out and you start drawing on them, what ends up happening is you make a mistake. And then you got to throw the piece of paper away, you got to start all over again. It's kind of like the old typewriters. And I don't remember where I was, but I mentioned the typewriter, and there was a couple of students in the class who had never heard of a typewriter. Maybe it was this class, actually. No, maybe it was at IT, I'm not sure. It's like the Rolodex. They never heard of the Rolodex either. But, anyway, typewriter. Word processor much better than typewriter. Going down memory lane. Typewriter was bad. You had a correction fluid. You had it was bad. And the same thing with low fidelity prototypes. Make a mistake, you got to start over, or otherwise you got all these corrections all over it. Not very flexible. And your first prototype's not going to be your last. Your prototype's going to change. Your design is going to be in progress. A lot of people they do prototypes and they make an executable file out of it in Visual Basic, and then they send it to whoever. They can't change it. You can't do anything with it. It's an executable file. So send the source code files. Send here's my project here, and then it's kind of like Google Docs. They can open it up. They can change it. They can save it. Send it to somebody else. Somebody else can look at it. Materials and implementation. Choose materials that are easily manipulated, ones you feel comfortable using. You seriously don't want to spend all your time learning the prototyping tool. If you spend more time learning the tool than you do creating the prototype, you've defeated the purpose of the prototype. Make something that is pleasant to look at. That's actually extremely important because consumers judge everything by its cover. So if the software looks bad, it's in offensive colors, it's hard to read, the font's too small, font's too big, I don't know, it just doesn't look hip or something, consumers will just throw it away. Who? They won't even find out what's underneath the hood. They don't even know what's going on inside of it. Allow for strength. Create prototypes that can handle a lot of use. Little paper prototypes, really, spill something on it. They get old fast and they wear out. Reject ideas that are too fragile and complicated whenever possible. Simplify things. Make it simple. Keep it simple. There's an interface prototype example, and this is a web. To give you some examples of what to do. Implement it with HTML. Multiple user interfaces here's an iteration cycle based on extensive user feedback. The design is being revised. It's under review. So you have a live webcast interface going on. You have the original, the current, the proposed system. And kind of 3 different stages that are being represented. And this can actually happen live. You can actually, put up new pictures, new screenshots or something. So it's just one way of and this is a prototype example, which is kind of similar to PowerPoint, actually. You have different slides and you thumb through the different slides, which is a prototype, if you think about it. So for your project, what type of prototype will you need? Software prototype? When I say software prototype, I don't mean an application. If you want to put together a software prototype using Visual Basic or something, or C++, Java, do whatever you want, that's fine. The minimum you need is a low fidelity, maybe PowerPoint, or Word. You don't have to use PowerPoint. You can Microsoft Word if you want. You can use Excel if you want. don't know what you do in Excel, really. I've seen a lot of Word and PowerPoint. Materials, software tools, Word, PowerPoint. What should you implement in the prototype? That's the more interesting question. So most people are going to implement the look and feel. They're going to implement what the screens look like. You don't have to. You don't have to implement that at all. In fact, if you don't have any artistic ability, you don't know how to do screenshots, you don't know how to draw, you don't have to. What you can do is implement maybe a list of the features. Maybe go through the requirement spec and kind of map out all the functionality and prototype that by coming up with bullet items or something. It has an input. This application will do everything. It will clean your floors, it'll shine them and buff them, and it even toasts bread, and all this other stuff like the commercials do. Because if you think about it, what is a commercial doing when it's showing you a product? It's prototyping it for you. Look, here's the Miracle Vac, and they pull it out and they start using it. Look, all this dirt is now gone, They don't have those commercials anymore. Those are fun commercials in the old days. They had, here's some gasoline. There's some gasoline. Here's some grease. Some grease on there, and one wipe of the Miracle Wipe. Look, it's all gone. And then here's the competitor's product. Think, oh, look at the paper towel tore off or something. Well, that's prototyping. So you can do that in your presentation if you want to as well. Here's what my product's going to do. Here's the vacuum going over. Look, it got up all the dirt. And here's what your prototype's going to look like, maybe. Because most of you are probably not creating vacuums. You're doing something software-oriented. And your prototype's going to say, here's scenario number 3, the analyst subscriber screen. Actually, this looks like an old-style website. This is an old PowerPoint lecture, so it is kind of old. It's a little outdated. I probably should update this a little bit. So the prototype lets you simulate a lot of the detail of the interface. Allows you a presentation to the user. It gives you, this is what I'm thinking about, and I'm writing it down, and here's all the charts and stuff that are going to appear. And sometimes they call this a Wizard of Oz method, because you're dreaming up what it looks like, and you're putting it down on a piece of paper, but it's not, the real application's not going to look like that. It's just a prototype. And it's kind of funny, there was a show that took prototypes, old prototypes, and compared them with the real product. Some of them were dead on. Some of them was like, that's the prototype for that product? Looks completely different than you'd expect, Well, where'd that come from? You're talking about the right product? The prototype, looks totally different. Because maybe it is, actually, because maybe they looked at that prototype and went, can't do that. That's ugly. And then they decided to switch it around or something. Which is another good point I forgot to mention. The prototype does not have to meet the requirements and match the final product. The prototype might be a good make or break point as well. Because you might put together the prototype and go, oh no, this is ugly, or oh no, this isn't going to work, and then scrap the project at that point. Or you can put together the prototype and decide on a better way of doing something after you've seen it implemented. And the whole example of the foot mouse is a good example of that. In fact, they're not even on the market anymore, but there used to be the foot mouse. I think I mentioned it already in this class. Had major problems. They put together a prototype, and they went, oh no, product is unusable. How many people have that much space underneath their desk to put and to move the mouse around? Plus, you're going to take your shoes off to put your foot on this mouse, and who else has put their foot on? I have problems touching people's mice with my hands. I'm certainly not going to take my shoes off to put my foot on somebody's mouse. Not going to work. It's the same thing, and I'm surprised they haven't invented something for the airport yet, for walking through, the disposable booties for your feet or something. Because I have problems in the airport too. But long story short, prototype said, oh, no. Not a bad product. Not going to work. So you have to change the design completely on that one. So the product's not going to look like the prototype. There are some foot mice out there, by the way. They're more like gas pedals. They're more like controls. They're more like pedals than there are. And it's for handicapped people. For people who have, you actually can put them on the bottom of a wheelchair, and all it needs is pressure. It's pressure sensitive. In Just the same way as there's mice for arm movement that doesn't look like a mouse that goes on a desk. It's a 3D mouse, goes in the air. It's an air mouse for people who can't, quadriplegics and stuff who have limited arm control. So, but yeah, I know the prototypes look nothing like the real product in some of those cases. So, using prototypes to animate a benefit, another reason, easy to discover problems. For the end user, suggest how requirements might be improved, which is what I've been just talking about. Maybe used to develop system tests as well. Let's test it to make sure it's not offensive. Let's make it sure that it's usable. And might be used later in the system validation process as well. Maybe back-to-back testing with the final system. You can't actually test the prototype the same way as you test the final system, but you can use it to come up with your test cases. If you have a high-fidelity prototype that practically looks like and runs like your finished system does, then you can use that as a means to develop the test cases, or to practice the tests on the prototype and then implement it on the real one, or run them on the real one. That's a pre-testing method. Because you might not have access to the real system until the very last minute. You've outsourced it, hasn't come back yet. When it comes back, you have a week. It's hard to develop all your test cases, put together your test plan, and test the thing in 1 week. So if you have half of it done already, you just, apply it to the real product, run the test through, automate it somehow. And as I mentioned before, it may serve as a stopgap system. So, yeah, no, we're not putting that out to the consumer market. It's not going to work. So delay the implementation of the final system perhaps until they come up with a better idea. And it might be revealed that requirements are inconsistent, incomplete as well. Because if you can't build a prototype, how are you going to build the real system? And a couple of final notes on testing the prototype. The scenarios are role-playing, no substitute for user testing. Test with users with similar backgrounds to the target users. And doing the design will give you a large set of expectations about what the users will do with the design. So you give them a prototype and they start using the prototype for something that, wow, I didn't think you were going to use it for that. And then oh, wait a minute, maybe we should have that feature in there. People are trying to use this for something else. Like, I don't know, going back to Chase example, they're trying to do wire transfers with this. And it just scans checks or something. Well, we have it scan credit cards or something as well. Or scan something else. So the test will reinforce or contradict your expectations. It's a learning process. And here's the picture of the learning process where we design, we prototype, we evaluate, we go back to the design stage. We go, okay, change the design, make the control to the left, to the right, change the position, change the color of something. So it will expose problems, hopefully. And then you can, attack the problems in hopefully some sort of organized manner. And then work on the features, and then, go back, fix another one. So one feature is probably going to, fix one feature might break another feature, something of that nature. So for project work, continue working on your design spec and continue to work on your prototype, or start working on your prototype. It's a good thing to start considering at this point. Just make sure this is still running. Yep, it is. Okay, good. My icon goes away. Doesn't make me feel good. As a user, I want my icon to be there all the time. That way I know I'm recording. So, if I were prototyping that, I'd say, make sure. Actually, that would be a feature. This is the real product, so that would be a feature in the recording software. Software metrics. I'm only going to talk for another half hour or so, 45 minutes, so don't worry. This lecture is pretty quick, actually, because half of it is just on concepts, but you need to know this for the final exam, just in case there's a question on software metrics. And there probably will be something related to this concept, because it is part of the course. What are they? What are we looking at? Software metrics measure something that we're concerned with in deriving a numerical value on an attribute of the software product in the process. I'm trying to put a number on something, give it a score, give it a measurement, and it depends on what we're trying to measure as to what type of evaluation we're going to do, what type of number we're going to put on it. It allows for objective comparison between techniques and processes. It kind of works with, I like to talk about measurements and metrics after prototyping, because prototyping, we're sort of doing a mimic of the product. And software measurements and metrics are sort of a mimic of the processes, or as the software as well. But it's more of a quantitative mimic. It's like, how can you tell how effective something really is? I mean, who's to say this is good or bad? Who's to say that the software fails or doesn't fail? Or that the programmer is effective or not? Is it measured on how many lines of code they write? How fast they finish a job? Because we all know, the faster you finish a job, the worse, the lower the quality of the work that you've done. And it applies towards everything in life, not just coding. So, companies might have to introduce measurement programs, systematic use measurement. Still uncommon, actually. So it's very uncommon. It's still being used for certain things. What is the software metric? Well, it's a quantitative measure of the quality of the software. So we can give it a score. And some people consider this junk science, which is why I'm not going to spend too much time talking about it. But the concept of measuring the software is important to know in software engineering. You might have difficulty in testing, you might have difficulty understanding what the software is doing. So at the beginning of the software project, you've done your requirements. At that point, you can start doing some metrics on that. And you can say, one of the ones you're going to need to do, whether you flip a coin or you actually come up with a quantity, some quantitative way of justifying, is how many hours is it going to take you to build this thing. So you can like count up how many subroutines there are, how many functions there are. You can count up things about the software and say, this is going to take 2 people working 2 weeks, or 1 person working 1 week. And a lot of people guess at this stuff because sometimes the metrics are wrong. So what ends up happening is you learn how to do it, and you keep it, and you keep the method going, and you apply it to all projects, assuming that this isn't your first project. If it's your first project, you're guessing, essentially, because you don't have any way of measuring it. And what you're measuring is the previous work you've done. So you know, as a student, how long it takes you to write a research paper, or it takes some people longer than others. And maybe the person who writes the research paper in 2 days, it only takes them an hour to do math homework or something. Maybe, you know that. So software engineers have basically the same process they go under, but a lot of companies try to formalize it. Instead of just having a gut feeling or an intuition or something, which you can do in your own personal life, in a company environment, the customer's going to want to, how long is this going to take you? You go, well, I feel like it's going to take a week, 2 weeks. And then they're going to go back, what do you mean you don't know? Or if you say, it's going to take 2 hours and 15 minutes. Then they're going to go, okay, 2 hours and 15 minutes are up, you're late. What's wrong with it? How come it's not done yet? It's kind of like auto mechanics. When you go in to get your car fixed, they have to charge you, but they tell you how much they're going to charge you before they actually work on your car. Because they go in the book, and the book says, a trained, certified, such and such mechanic should take them 2.5 hours to install this exhaust system. So they go and to the customer, here's the part number, here's what it costs for the part, here's 2.5 hours to install it. You bring your car in, and it's out in 15 minutes. But you say, you charged me 2.5 hours. Oh, that's because we were really good, and your car was already cooled down. We didn't have to wait for your car to cool down, and I don't know, all this other stuff they're going to tell you. But that number doesn't match the amount of time they actually take on your car. Same thing in software engineering. So what ends up happening is you have to tell the customer, well, based upon these metrics, these measurements that I've come up with, where are you taking those from? Best practices, what your company's done in the past, what the last programmer did. How are you going to know how fast every programmer is going to work? Well, you put this scale together, you put the chart together and say, well, it's got 5 modules to it, and it's got 25 functions and 29 variables, or it's got a ton of variables. Oh, it's got database connectivity, and you take a look at the features, or you take a look at the number of subcomponents or something, and you apply it to the calculation. It comes back and says, this is going to take 3 weeks to do, and I'm going to need. If you want it done in a week, I have to put 2 or 3 programmers on it, because each one of them is going to have to take up a week's time, And then you can figure out how much that's going to cost you. Because here's what happens when you build your first project. Acme Software Engineering, first project, first customer, you lose money. You always lose money on it. You never make any profit on it, which is why a lot of software engineers go out of business real easily on their first project. Because you're always going to underestimate it because you want to be competitive. Because if you bid too high, if you come back, they say, okay, give me an estimate. I don't know, $10,000? Okay. And you're just picking that number out of what you think is appropriate for it. You haven't gone back and haven't looked at your expenses. You don't know what your expenses are going to be. You don't know how long it's going to take. And then you end up having to pay some top-notch developer because he's the only one who knows how the tools work, and he's the only one familiar with the technology. And he works very slowly. Or he's overbilling you because he's working out of his house and he's spending half of his time doing another job, but he's charging you for it. And he's taking 2 weeks to do it because he's milking you, because you're paying him by the hour instead of by the job. Long story short, you're going to lose money on it. So every software engineer wants to know, how do I estimate this? And unfortunately, this is junk science. There's no way of actually estimating how long. It's just like the car business. It's hard to tell how long it's going to take the mechanic to fix the car. There's guidelines for if they have a certain education, certain training, it's supposed to take them so many hours. But they pad that as well. So, who knows? It's guesswork. It's junk science. So what are you measuring? You could be measuring software complexity, how much human performance is going to need, or you could be measuring computational complexity. How hard is the program actually going to be to write? So the metric itself is any type of measurement that relates to the system somehow. The processes, you can actually measure how much time it's going to take you to write the documentation. How much time is it going to take you to do the analysis? The best metric that I can come up with, from what I've seen to be the most effective, is how much testing is going to be needed. Based upon the complexity, that one's probably easier to figure out. If you've got, let's say, a heart monitor, software you're going to put on a heart monitor, you're going to have to spend 3 times the amount of time testing this sucker than you will for a Microsoft Word or something, because you can't have the thing fail. So if reliability is a huge issue, then you have to actually just guess at that and allocate twice as much as you'd normally think. And there's certain standard metrics. As an example, there's the one that goes, it takes twice as long to fix the bugs than it does to actually write the code, which is kind of true. So whatever time it took for the programmer to write the software, if you're having the programmer fix the software, times it by 2. So if it was 3 weeks to write it, it's now 6 weeks to debug it. So 3 weeks turns into 9 weeks, essentially. And that's expected as a minimum. So it probably could take longer than that. So in the old days, there was like lines of code. You can count the lines of code, and that's how much you should pay the programmer. And then people started padding the code, make more lines, make it less efficient, add a lot of comments. And then, what is a line? Things like that came up. Allow the software or the software process to be quantified somehow. Measure the process or the product itself. It can also be used to predict product attributes or control over the software process. So here's the predictor and the control metrics and how they're supposed to work in terms of the big picture. We have the software process. We have the control measurements. We have the management decisions that go into that. And so depending upon these control measurements that we're coming up with, the manager can say, we need to hire more people, or we need to train more people, cross-train, or do certain things from a business perspective to make this process run a little faster. What they're trying to do is speed up time, because nobody wants to spend any time doing anything, because time's money. Here's some commonly accepted heuristics. 70 to 80% of the resources are spent on maintenance. Yep. So when does maintenance happen? At the end, when you don't have any money? So it costs you longer to maintain, which is why nobody includes maintenance anymore. You're not going to maintain something. Here it is. Have you guys heard of the taillight warranty? Tell you, the warranty lasts until you can no longer see my taillights. You drop it off, you drive away. When my taillights are out of view, so is your warranty. because that's how it works. You know, no more maintenance, because otherwise, maintenance. And I haven't really talked about maintenance very much in this class, but maintenance is new feature addition sometimes. People have an interesting concept of what they're referring to as maintenance. Oh yeah, can you fix this? Oh yeah, no, it needs this new feature. Oh yeah, it needs this other new feature and this other new feature. And you're really doing upgrades instead of maintenance. Or you haven't done your debugging or your testing, and that's part of your maintenance because the thing doesn't work. Average programmer, this is outdated. 10 to 15 lines of code a day. Actually, even in the day, that's pretty low. I can write 10 lines of code probably in about 10 minutes. 10 to 15% of the project is coding. Don't know about that anymore either. It's kind of a smaller percentage, I believe, at this point. Modules should contain less than or equal to 50. That's outdated. Span of control, outdated. So that's why I'm like, a lot of these statistics are outdated because programming languages have changed. We have object-oriented languages now. 2 lines of code gives you half the program. I don't know, not really, but you know, it can give you a lot more than it used to. Uses of the metrics maybe to identify parts of the program most likely to be hard to work with. Aid in the allocation of testing and maintenance resources, predictors of the size of the effort, number of bugs, and also feedback to programmers. You know, like what should be fixed next. Might be, you know, well, it came out of this feature. Oh, this feature is really hard. Oh, okay, that's going to take more time to fix or something. Here's some classifications of software metrics. We have size metrics, measuring the size or the amount of effort to take to build something. Logical structure metric, which is going to get at the complexity measurement. Data structures, complexity again. Interconnection metrics. The more interconnections you have with the software, the harder it is to implement, actually, and the harder it is to test it and maintain it. Object-oriented metrics, a whole brand new breed on their own, measuring the cohesion, the connectivity, the amount of messages, amount of interconnections, and function points. Function points are pretty popular still, and that's taking the software, breaking it out into different functionality and counting it up. If you do that, you can actually predict pretty reliably how much time it's going to take you to build it, depending upon the higher function point. You know, depending on how high the function point is, it's going to take you more time, more effort to build it. So what I'm going to do is kind of flip through all of these. You do not have to know any of the particular techniques that are used for any of these categories, because a lot of these are outdated. Take a testing course. Take a QA course. Better choice. This is just an introduction to software metrics that I'm throwing in right after prototyping just to give you some exposure to the concept. You may or may not see this on the final, actually. And for those of you who aren't in the loop, at the end I'll go through the schedule again. And we will have a review so you can know what's on it the week prior. I'll tell you when that's going to be. Size. How many lines of code are there? Standard definition. Problems, obviously, what's a line of code? You know, what's a comment? And padding the code, stuff like that. Number of tokens, you can count those. Function count, that makes sense. Counting up the number of functions within the program makes a lot of sense, actually. Problems with function count is what's a function? And will it work with languages that don't use functions? Is a function a module? Is a function a subfunction? How many functions are inside of that function? How are you going to break it out? Logical structure maintenance metrics, the complexity. These are using acrylic graphs. They're using all sorts of different data structures to measure out the number of paths through the program, the number of loops, number of substructures. A little harder. It's more of a systems programming technique. It's a little harder to measure it, and you're relying upon algorithms, graphing algorithms, to create, in this example here, the complexity, the cyclomatic complexity algorithms that you have to apply. And what you do is you create a graph, and then you measure the leads on the end, and you measure the number of paths through, and the number of nodes and things. And you're coming out with a boundaries set for the system. You have to decide where the system stops at one point, and the new system begins. And you're essentially counting up. And this is what I call borderlining on junk science, but it really isn't. There's a method to it, but learning the method and applying it appropriately might be a challenge. It's time consuming. And what are you going to get out of it? It's hard. It's easy. You know, the measurement isn't going to tell you very much. Data structure measurements, actually looking at it from a data perspective and from a computational perspective, the amount of data that's being used. Usually, in the old days, that was an issue. Now with databases and connectivity, a lot of that's simplified. We have libraries, drivers, and things, connects to databases just fine. We don't have as much data storage in terms of files and our own kind of proprietary data structure that we might create to keep something with. We have easier techniques these days. So technology has improved the complexity of data in general. Interconnections technology has actually improved that as well. If we have a highly distributed application, highly connected, one with a lot of internet connections, we're going to pick a platform for it that's going to complement it, like a Java Enterprise environment or something, or NetBeans, you know, I don't know, some platform, network platform that's going to support it. You know, make a .NET application out of it or something. Which this kind of gets a little outdated again, because you're going to go measuring interconnections. You're going to qualify, you know. In the old days, we didn't have the internet, so to build a network application in the old days was a lot more complex than it is these days. Now you just throw it out there on a website. Hello, everybody in the world can connect to it. Not very complex anymore. Object-oriented complexity metrics only work if you're building an object-oriented program. Because you're not working with object orientation, this is not going to help you at all. And if you are working with it, you're going to spend a lot of time doing the metrics. When you probably could just write it, because object orientation was supposed to, you know, facilitate reuse and be easier to write. And, yeah, so you're going to spend a lot of time doing metrics on this. You're going to probably, you know, counting up the number of children, the number of classes, number of inheritance in the tree. Coupling might make sense, actually. Tell you something about the complexity. Response time, cohesiveness, you know, the interconnections, stuff like that. Function points, still valid, actually. And here you're measuring the amount of functionality in the system. Because what are you really building? You're implementing functionality. So how big is your requirement stock? How much functionality are you putting in? If you're writing hello world, it's going to take you an hour on a bad day to put hello world together. If you're a brand new programmer, you've never programmed anything before, you can probably write hello world in less than an hour, I would think. But an hour would be a good estimate. If you're an experienced programmer and you're putting together hello world, 5 minutes, 2 seconds. So compare hello world with an accounting program. We have more functionality. So you count up the functionalities, and we got this module, this module, this module, this module. And you put it into increments, is what most people would do. Say, well, compare it with what we've done in the past. Well, we wrote hello world. How many hello worlds are in this accounting program? Probably about 500 or something, you know. So it takes an hour plus times 500. So you figure out what it costs in time and money to put together and resources, one section or one function point, and you multiply it by the number of function points you have, essentially. And you're putting a quantitative measurement on a bigger picture. So not every application has the same number of function points. Some of them have more, some of them have less. That's what is a reliable way that, like, a lot of people use today in terms of function point analysis. Excellent way of kind of, because it's accurate. I mean, if you know you got to put 3 hello worlds together, it's going to take, you know, and you're a brand new program, it's probably going to take you 3 hours to put it together. Hopefully. So, it relates directly to the requirements. Available early in the development. Right there when they start telling you what you need to build. Use as a productivity measure as well. So you can measure the productivity of something. How do you do it? You put together a weighted sum of the following. External inputs, external outputs, queries, files. And you put together, and this is actually by type of application. On the left-hand side we see, you know, a money transfer program might have 105 function points. 105 hello worlds in there or something. And that came out of all of these hello world categories. So let's say we have a hello world, and then we also have a different type of program, you know, like a, I don't know, like a calculator program or something. Or these are just arbitrary measurements. In the example, we've got inputs, outputs, data, connections. We pick what we're going to measure. We add up. Well, it uses a lot of data, but it doesn't use any interface. doesn't have any inputs or doesn't have any outputs. And this is where the trick comes into playing: is what are you adding up? What are you quantifying? So you come out with a function point for it, inquiries, tables, interfaces, add all that stuff up, and then say, well, for C, the average source lines per function point is 128. For assembly, it's 320. If you want to count lines of code as an example. In my example, I put in, man hours, work hours, instead of lines of code. You can use anything you want to qualify it, but you pick the language and say, well, in this particular language, if you wrote it in Java, if I had Hello World and I was going to write it in Java, it actually wouldn't take as long as C++. C++ would actually take a few more lines of code, probably. Because in Java, I'd just go class Hello World, print something to the screen. Like 1, 2, 3, 4, maybe 4 or 5 lines of code. C++, I'd actually have to include all this stuff, and I'd have to make a main, and inside of main, I'd have to, print out to the I/O something, and I have to close main, and a little bit more lines of code probably. So you could probably, what is it? Probably a 5-minute difference or something. The goal of the function point analysis is to create a metric that can be used. It meets 5 goals. It deals with external features of the software. You're looking at the functionality. It deals with the features that are important to the users. So you can actually kind of, if you want this feature, and this feature, it's going to take 3 weeks. If you want to hold off on that one, it's going to take 2 weeks. And you can kind of build in increments if you wanted to. It can be applied early on in the product life cycle, like right in the beginning of the development. Because right after you have the requirements, you can do function point analysis on the requirements. And you can come back and say, this is how much time it's going to take, hopefully. Provides linkage to the economic productivity as well. How much is it going to cost you as well? And it's independent of the source code or the language. It's just a number you're throwing out. So, and the function to keep in mind is something that the processes inputs to create outputs as a function. It takes inputs, creates outputs by definition. It doesn't have to. It can be a unit of measurement of anything. So it represents the amount of function delivered by the system or in the system. So, function point analysis is coming up with a plan to use function points to determine something about the software in terms of measuring. The process of counting the function points, using the count to estimate the software metric method to break the system into smaller components. So, metric assumptions. A big, huge one. That software can be measured. How do we know we can actually measure software? That's an assumption. Which makes this entire lecture obsolete if you think about it, because if we can't really measure software, then why are we even bothering to put a number on it? The problem is we have to. So it's just like trying to measure people's work. How long does it take you to walk? Well, you probably could figure that out. Depends on the speed, but labor, stuff like that, costs. Unpredictable sometimes. Relationship exists, and we're assuming that there's a relationship that exists between what we can measure and what we know. Are we even measuring what we think we're measuring? Do we know what we're measuring? And the relationship can be formalized, validated. It's another assumption. It might be difficult to relate what we're measuring to the desired quality attributes. Sure, we can write Hello World in an hour. Well, 5 minutes. Is it really Hello World? Did we leave anything out? Do we make a graphic version of Hello World, or is it a text-based version of Hello World? Probably take just as long with Java. If you wrote a graphical version of Hello World in C++, it might actually take you an hour. In Java, it would take you 5 minutes. Interesting. And here's the internal and the external attributes in terms of the function points we decided to use in that example. And we're assuming that there's a relationship between the two. That we have maintainability, reliability, portability. These are good quality features of software. And do they actually relate to one of these measurements that we're making? If we counted up the lines of code or length of the user manual, does length of the user manual say anything about its usability? I don't know. Now we don't have any manuals anymore, so we can't even use that. So, they used to say how big the manual was. They use that, if the manual is so thick, that meant the software was a higher quality. That's like people judging the book by the cover. How many pages are in the manual? And it's actually kind of deceptive. And so now, if you take a look at some of the products that are on the market, people are starting to put in more manuals, actually, because the products that don't come with manuals, that don't come with cables, that don't come in, minimized packaging, aren't perceived as the same quality as the package that, like, Apple as a classic example. Why in the world print out all that stuff? Stick it in a special colored, flat, matte black case, and the casing on the manual and all the documentation and the backup discs and all the things you're never going to even use, you're just going to throw them away on an iPod or on a computer. It costs them a lot of money, but why do we think that those products are higher quality? I mean, no one argues with that. It's, it's an Apple. It's an iPod. Well, yeah, it's going to come with a manual. Yeah, it's going to come with an extra USB cable. It's going to have earbuds in it. It's going to have all this stuff, and the package is going to look good. So it tells us, the perception is that it's a higher quality. We'll pay more money for it. So now cheaper products are starting to do the same thing. So, and in the old days, for a long time we went the opposite extreme, and Apple got away with it for years, and still doing it. They never changed. They never skimped out. Now you buy a computer, you buy an HP computer, it comes in a brown box. You're lucky if you get the brown box with printing on it. It's usually an OEM box from the manufacturer who sold you the computer. Got a bunch of stickers on there. Half the stickers are crossed out. Other stickers are put on it because they swapped out stuff on the box. Reuse the box or something. You open it up and it's in a generic cellophane wrapper or something. There's no manual in that box. Unless you're buying a compact, but then I don't know if they're doing any more manuals on compacts anymore either. But most modern day computers aren't going to give you a user manual. You'll be lucky if you get the original packaging from the OEM operating system. You'll be lucky if you actually get a backup disk of the operating system that's installed on that computer that you bought. Usually it's on the hard drive, or they tell you when you turn it on, make your own backup. Where's my disk? My nice flat matte black special package envelope and all the rest of the stuff comes with it. Okay, that's enough on that. Alright, that was basically discussing how our perception of how there's an interrelationship between software quality and what we're measuring and what we're looking at in terms of quality of manuals, documentation, stuff like that. Help screens, stuff like that could apply. Alright, measuring process goes out hopefully throughout the entire life cycle of the development project. Data collection is part of it. Actually, it's kind of like garbage in, garbage out as well. If you are looking at bad data, they forget all your metrics are all wrong anyway. Collect some good data, hopefully. This is going through a way of automating the data collection itself from fault information. In fact, this is kind of like what Microsoft has done with the, do you want to send a message to Microsoft after your computer has crashed or something has fatally gone wrong? This little screen that comes up, it started in XP, I think. Yeah, send a message to Microsoft. It goes into a big old repository of messages, and it helps them figure out, wow, everyone's computer's crashing. Oh, there's a bug. Oh, well, let's fix the bug, put out a patch. So it's a way of collecting data, essentially. The data accuracy, what the data is telling you, product metrics, static, dynamic metrics, different categories. Measurement analysis, not always obvious what the data means, what the analysis is meaning. It could be the fact that what you're measuring is not necessarily what you're getting, or you're not looking for the right thing in the data, and the data's telling you something else. Like maybe the users are using it the wrong way, or maybe they're pressing it in the wrong order, using the product in an unattended way, and that's why all these errors keep happening or something. So here's some key points in conclusion on your quick overview of software metrics as it applies to software engineering. The measurement itself gathers information about both the software process and the product. We can measure the product, we can also measure the difficulty in creating the product. We can also measure the effectiveness of the development process, how well our software development lifecycle is working, how well our stages are working, how productive we are. And we can also product quality metrics should also be used to identify potentially problematic components. We usually have a goal or a purpose for why we're performing the measurement, and hopefully has something to do with problematic things that we can change or fix. There are no standardized methods, so no standardized and universally applicable software metrics, which is why I started out saying I don't even, I'm going to go quick through this because there's nothing that's standardized. And most of this is what a lot of people consider junk science, because how can you measure software? I mean, you can take some approaches to it, but none of it is 100%. And this is another reason why a lot of people don't consider software engineering a true engineering discipline, because in other engineering disciplines you can put a quality measurement on something. You could, assess the earthquake stability of something, of a bridge or something. How effective or interference on an electrical signal or something, or how you can actually measure. Software's hard to measure because it's a man-made. It's almost like a painting. How do you measure the quality of an artist's painting, a portrait? You're only going to measure the brush strokes, how many strokes it took them to make the painting. What is it? Is it aesthetically appealing? Is there any documentation that goes along with this painting? It's kind of like software. You can't measure it accurately. It's kind of a judgment, sort of subjective judgment. So what do you need to do for your project in terms of software metrics? Nothing. You don't have to actually put together any type of metrics to measure anything about your software. So what we're going to talk about next week is quality assurance, actually. And for those of you who came in late, so for those of you listening to the video at home, you can stop it. We're done with the lecture part. So, for the administrative part of this class, for those of you who came in late, I have posted the final exam schedule. Monday, on the 8th, HTML class, Unix class. This is our class right here. So, if you don't want to take it on Wednesday the 10th of August, you can take it on the 8th or the 15th. Or you could take it on the 17th if you'd like. I figure because you're here on Wednesdays, you're probably going to be available on Wednesdays. So we don't have class on the 17th because they're taking an exam. So if you want to take it on the 17th, you can take it on the 17th. If you want to follow the schedule, it's probably the preferred way. This is when I'm going to hopefully have my software engineering people show up. It's going to be on 8/10. However, if none of these days work for you, you don't have to get approval ahead of time. Just show up when it does work. If you have multiple classes with me, you can take all the exams in one sitting. An hour and a half to 2 hours for the exam. It will be multiple choice, closed book, closed notes, closed internet. The week prior to Monday the 8th, I will be reviewing, which is not next week, but the following week. We have 2 weeks left before all this stuff starts. Next week, we're going to talk about quality assurance in this class. The following week, we're going to have our final exam review. And I'll tell you, because I'm actually in the process of writing the exams right now. I'll tell you everything that's going to be on it, subject by subject, so you know what to study for. I'll also put it out on YouTube so you can see. You can watch the video if you miss it. But no groups. So last time I did this, I divided everybody out by their alphabetical order of their last name, and nobody showed up in the right groups. No, in fact, most people showed up about noon. 11 to 2, 11 to 3 was the busiest time. So if you want to come in and beat the rush, beat the hassles, beat all the confusion and stuff, show up at 9 o'clock in the morning, and then you'll have a pleasant experience. Or show up, some people have to work, and then last time I got people going, I can't come in at this time, I have to come in at this time. Okay, come in whenever is available, whenever you are available on this day between 9 o'clock a.m. and 5 o'clock p.m. And if you miss it, you come in at 5 o'clock, and you're going to expect to take a 2-hour exam, you're not going to have enough time, so I'm going to send you back the next week. You have to pick another time if that doesn't work for you. And none of these are weekend days. I can't believe how many emails I've gotten from people requesting weekend days. Weekend classes go on weekend days. Weekday classes go on weekdays. I can't be here 2 weeks straight every day of the week. These are the days that I'm going to be here. Questions? And this is also on the behacker.com site. I have stuck it out there. Here it is, if you want to find it, so you don't have to write anything down. Nope, then we're done for today. I'll see you next week. And so let me just take a look at the calendar real quick. Actually, let me just make sure I'm quoting this correctly. Yes. Next week is the 27th. The following week is the 1st, 2nd, the 3rd of August. So our final exam review is going to be on the 3rd of August. And our exam starts on the 10th, which is the next, where did my calendar go? The following week. Good? Okay, good. Okay, enjoy. Should be hot outside. Questions? I'll get the emails. I'm sure I'll have plenty of emails.